Hey everybody, David the AI Guide here. Welcome to another episode on the AI Guide where we're making AI human. Is there a new breakthrough pending in 3D printing? We'll talk about that in a minute. But first, click the links below. Get my book on Amazon, The Beginner's Guide to AI, A Short History of AI and Current Impact on 10 Different Industries. And the second link, free resources for you to learn more about AI, much more than we can do in these short episodes, and prepare yourself for this highly automated future coming very soon. So thanks so much for tuning in, and let's get going. So we posed a question: is a new breakthrough in 3D printing pending right now? There was an article in Bloomberg, thank you Bloomberg, talking about a not new company, 5 years old, but newer company with some very high-powered people who have started it in the 3D printing space. We'll hear about that, and we'll also hear what they're up to and the impact it's going to have. Since it first began to receive mainstream attention about 15 years ago, and remember, we've talked how exponential technologies start out very, very slowly, a very, very slowly increasing curve, and then it hits an inflection point and shoots through the roof. This is a potential inflection point. We'll see. 3D printing has had a magical air to it, holding out the promise of turning every home into a miniature manufacturing hub while simultaneously upending industrial scale factories and the way they operate. But 3D printers have gained a reputation for being unwieldy, expensive, and slow. The utopian dream of printers becoming a household appliance as ubiquitous as the personal computer has largely faded. So let me say this about that. As you know, I say in the stuff we cover what I agree with and what I do not agree with, and I don't agree with what they're saying here, and I'm going to tell you why. It's very, very well known with technology development of new technologies that there's a lot of big hype at first, big hype, big interest, and then disappointment leading to a trough where the technology doesn't go silent, but everyone says it's not going to fulfill its promise. But then, lo and behold, it starts to take off again and goes truly exponential. This happens with all technologies. And so we're in that trough with 3D printing, and specifically, I think, with household 3D printing, which this article is not about. We will all have a 3D printer in our home, and it will make our clothes, it will make our food, it will make our beverages, it will be the precursor to what you see on Star Trek of the replicator that can turn energy into matter. That's for a much later date, but I expect and believe that will one day happen too in the distant future. So let's keep going. There has been more progress on industrial uses of 3D printing, although there too major players have fallen into a multi-year funk. My point about how technology develops. VCs, venture capitalists, continue to dedicate significant resources to startups promising innovations to fix the technology's underlying flaws. This is why it will ultimately be successful, because money continues to pour in to the R&D needed to get it to the point of commercial success. One particularly radical approach comes from Freeform Future Corp, a 5-year-old startup in LA. The company has raised $45 million so far. Instead of trying to build a single machine that can print 3D dimensional objects, Freeform is looking to turn entire buildings into automated 3D printing factories that would use dozens of lasers to create rocket engine chambers or car parts from metal powder. There's a bunch of different materials used for 3D printing. We've talked about that in a recent video. Metal powders and polymers, which is plastic. But Look for a short this week also on a whole new material with another breakthrough in 3D printing. So there's 2 breakthroughs in 3D printing that we're covering this week. The company, which has never before discussed its approach publicly, says the technique could allow it to make metal parts 25 to 50 times faster than is possible with current methods and at a fraction of the cost. This is why this may be a breakthrough, because 3D printing, we've talked about this in prior videos, historically has been low volume, high cost for very specialized parts. This is a focused effort by very sophisticated people that we're about to hear about to make this mass market. Freeform's co-founder and CEO, Eric Palich, spent a 10-year stint at SpaceX. SpaceX has famously pushed the limits of 3D printing in its rocket engines, along with many, many other technologies. SpaceX pushes the limits on everything it does. Palich led a number of its highest profile engine development programs, but he says both he and Musk knew that existing 3D printers were inadequate for the company's most ambitious efforts. When we told Elon how much the machines would cost for some of our new projects, he nearly lost his mind, and it always took an army of people to operate them. That's the kind of technology that is not mass market, right? So 5 years ago, Palich and fellow SpaceX veteran Thomas Ronacher started Freeform, hoping to rewrite some of the fundamentals of 3D printing. Typically, an object or a few objects are printed at the same time inside of a shed-size machine. While it can make just about anything, the amount of work this printer can do is limited by its size and printing area. We'll also briefly mention that in the short later this week. Freeform, on the other hand, is creating machines that can fill an entire warehouse. Its current factory in Hawthorne, California, right next to SpaceX, by the way. Inside, machines shuffle objects back and forth along rapidly moving conveyors so the system can work on many things at once. Other companies have set up multiple printers in a single facility, but this strategy does not improve the speed of production, so it doesn't scale. Freeform, by contrast, is redesigning the process by which 3D printing can turn raw materials into finished products. In a sense, it's akin to the establishment of the assembly line process pioneered by 20th century industrialists like Henry Ford, the modern production line. Freeform's backers are focused on the industrial rather than home-based production. The main thing they will be able to do is get the price of this down to where it's more like automotive manufacturing cost, which is really focused on lowering cost constantly, versus aerospace, which does not focus on that. Aerospace doesn't care nearly as much about cost. It cares about quality. And I was just previously at a company that was in the aerospace area, so I know exactly what I'm talking about on that one. 3D printers create objects from a range of materials. We just talked about that. A new layer of powder is applied and the laser fires again, then a new layer, laser, new layer, laser. A typical 3D printer today might have 3 to 4 lasers concentrating on a single metal plate where it builds up objects. A limiting factor is the rate at which the metal and plastic melt and fuse. Typically, the printer has to take breaks because it gets too hot. Companies consider it a success if a 3D printer is operating 60% of the time. That's very poor for regular manufacturing. In regular manufacturing, the goal is at least 85% uptime, and cutting-edge companies focus on achieving 90% uptime of machines. All machines require downtime and maintenance, but it needs to be 10 to 15%, not 40%, to be cost effective. Freeform looks to significantly reduce downtime. It has 2 parallel conveyor systems lined up with multiple metal plates traveling along them. Its 18 lasers fire non-stop while conveyors move plates in and out of the beams. Tasks like applying fresh metal powder to a plate or polishing the edges of a part take place in other areas of the machine, leaving the lasers to continue doing their work on other objects. Now, here's why I talk about 3D printing. I've been telling you for 3 years now it's because AI drives 3D printing. Here is the proof. A combination of cameras snap images at more than 70,000 frames a second, which no human can manage a process like that. Feeding the data into computer vision algorithms that orchestrate how the lasers fire. In other words, AI is controlling their entire production process in this section where they are doing the actual 3D printing. Where a standard machine can fuse about 3.5 ounces of metal powder an hour, which is a very, very small amount. Palage says Freeform does 5 kilograms an hour. So this is basically 100-fold increase in throughput, 100 times improvement in production. With the extra speed and lower price are bonuses. The real value of Freeform's system is how it monitors objects during the printing process. 3D printed parts can have flaws, and customers tend to use antiquated manual practices to check them. Freeform uses its host of sensors, scanners, and artificial intelligence software to assess quality and can make adjustments while something is being built. One of their customers says, the usual way we do this is a nightmare of testing samples and tweaking things. Freeform just prints something and gives it to me. As has so often been the case in industry, Freeform's current machine has seemingly revolutionary potential, but a short track record and just a few paying customers. It still has a mad scientist prototype quality to it. All technologies do at this point in development. All technologies do at this point in development. Nor is it as big or automated as the company envisions for more developed products. Iteration, we just talked about that. Iteration, improvement, step by step by step. And AI drives it to exponential speed. For the technology to be a real breakthrough, Freeform will have to prove that its machines operate quickly and cheaply enough to open 3D printing to a wide range of new applications and tackle traditional mass market manufacturing head on. Now here we get to the rub. The end goal, says Palage, is to have more lasers and more conveyors, adding up to a system of printers that can fill a 100,000 square foot building. That's a big manufacturing space. Jobs that typically take weeks will be done in hours, and few, if any, humans will be involved. It'll be a fully autonomous printing factory. And here we go again with my point about why you need to prepare. Click those links, get the book and the resources, is that technologists don't care about the human impact of technology. They don't care. They care about inventing something that's new, that's revolutionary, that's breakthrough, that will totally disrupt human beings from processes. They don't care. This is why I started the AI Guide. Prepare yourself. Click those links below. Focus on careers that are human-centric, human touch-centric. What are those? Someone recently said massage therapy? Yes. But also being a doctor, certain things surgery will be automated, but other doctor activities won't be. Nurses, psychologists, counseling. There's many, many fields that will survive and thrive. So thanks so much for tuning in. We'll see you next week. Look for shorts and be well.